So here we're talking about another feature. Its name is actually, we call it global VA, which probably should be global virtual address space memory region. Idea is when registering a memory, instead of previously we have to explicitly register buffer or certain memory region address size. We adding possibility to register entire create memory handle and consequently RK for RDMA access, which allows to access any address inside the process virtual address space. It's supposed to, honestly, it's supposed to improve no, main person of in our case, main purpose of this feature is to reduce number of arcs because it's we have currently certain limitations in IB, and this is supposed to fix. But as since it's no, it's common API, it's common feature. So it for other transport types, it also may be beneficial. Currently, we implemented it only for IB, where we used implicit ODP with some addition to improve implicit DP. In past, we already tried to implement implicit DP and experienced certain performance degradation due to it when it actually it was because actually it was handling memory access by updating and updating internal device memory translation table on demand. It has a certain impact on performance because such an update itself took severe ZMAN. So in this approach, we decided to try to avoid it by pinning memory, preparing memory by pinning it with mlock and populating it with UCT MD mem device will need, which is supposed to proactively prefetch information and update device memory translation tables. Honestly,
can I ask a quick question here? Like,
yes.
have you already considered the implications of performing lock on coherent platforms? Like Grasshopper, we don't want to use mlock, right? We don't want to pin pages.
It's a good point. I think currently mlock is enabled by default, but I think we should make it platform dependent.
Okay.
It's optional, enabled by default, but it should be very auto or according to reg and BMM types, which is according to the platform.
Right.
Good point.
And I would say, like, maybe I didn't catch it, but is there an improvement in using? Of course, there's a reduction in the number of registration keys if you use implicit registration. But other than that, in terms of performance, the other version of ODP is that any less performant than global VA desktop ODP?
The other version has a lot of keys.
That's the only difference, right? Performance-wise, they should be the same, right? Okay.
So, and not familiar with mlock, essentially it will pin entire physical memory, like what
The range.
is the range?
Yeah.
So how is different from regular memory pinning KBV? Like, is it any different, or besides
So
like
the intention is that it would be the same.
okay?
To preserve the previous behavior where something is pinned when you use it, and there is no additional cost of swap out, page faults, etc. To keep the performance at same level, the default is to use mlock. The difference is that
What do you say by default now? Like
whenever you enable the feature global VA,
okay,
the default behavior is not just to use ODP, but also lock the memory. Why lock the memory? So you wouldn't get excessive
page faults.
Yes.
You're trying to avoid page faults,
which is the assumption of and the working mode with HPC application until this point.
But that seems orthogonal to what ODP wants, right? With ODP, you want pages to fault, and you don't want to lock pages.
Yes, but the high-level goal of this feature is to reduce the number of keys that we use and still preserve the same behavior of application that we had so far as much as possible.
I missed one part. So what's the benefit of reducing the number of keys? Is it the key lookup time or something else?
That with applications that use a lot of small or medium buffers, they would not fail to register memory.
Oh, I see. So there's some upper limit on the number of registration keys.
Yes.
Yeah.
So it's
we have some issues in GitHub,
but like from API perspective, people still have to use RKey calls and exchange everything. So like if we don't change GCP semantics, it's all stays the same, right?
The objects the changes the object would not also create an underlying hardware object.
Well, I understand that, but UCP API will stay the same. They have to exchange RKey and everything. It just maps to the same RKey.
Yes, but on software, there's no limit.
I understand. But like, I'm wondering if...
I mean, if all transports supported global VA, we can think of introducing an extension that to have a global VA key also on API level.
Yeah.
And somehow hide it or whatever.
My point is like
emulate it if
like the pain of keys is just management of keys. People don't want like
yes, but on the other hand, if there is no ODP support in some cases, even shared memory transports or whatnot, we need to create a symmetric heap table or something like that in UCX.
I feel like there's a trade-off here. One, you're trying to reduce the number of RQs, but the trade-off being that you're increasing the number of pin pages, which doesn't imply more memory pressure.
Doesn't change. Still same amount of pinned pages.
With ODP, you
don't pin with ODP. He's saying
compared to ODP.
Yeah.
ODP with no pinning, right? There's no memory pressure introduced because you're not pinning pages.
But you're comparing it to something else. So there are two aspects here. One is the requirement to have migratable pages on specific platforms, on some platforms, let's say, and the other is to avoid the number of keys. And there are some intersection between those requirements. And the missing part, as you brought up, is that on platforms where we don't want migration, we don't want to lock pages. And then it would be the same behavior on such platform, but on platform where we can and want to pin it would also preserve the existing behavior.
Agreed. And strictly speaking, this only applies to system allocated memory. There's no question of any of this for device. Okay. That's all. I have.
Okay, so sorry, Artemy, for interrupting this internal discussion. You can continue.
Honestly, it's all.
All right.
So I think the main takeaway here is to check this behavior on Gray software.
Yeah. Or not enable this on their software.
Not like not enable at all, but we need to change the default behavior of floppy.
Okay,
Well,
yes. Yes, agreed.
I don't. This might affect AMD systems as well, right? This unified HBM. Edgar, this may they may impact your systems as well. Like, I don't know what you want to do on your systems with unified HBM.
With unified HBM, there's no migration.
There's no migration.
It's just the one HBM.
Just one HBM. They don't
Yeah.
have pages or anything.
So I think it should be fine for there.
Yeah, I'm wondering if I should explore semantics where this gets exposed to the user just to make users' life easier. But yeah, I can see the downside. Like once you do it, application will be non-portable, right? Because not everybody will support.
Oh no, if we add it to API, it has to be portable and we have to emulate it if it's not supported.
Yeah, then it becomes hell. Then emulating this behavior in software is pretty hard.
Yeah, the thing is that most biggest users already solved the remote key management.
Yeah,
They are used to it. So even if we add it to UCX, it wouldn't be removed from biggest libraries. They
No.
will still have to keep it for things which are not UCX.
I agree.
So like redundant work, I think.
Okay. Let's see if there's any additional questions online. I don't see anything typed in. Any questions?
So if a NIC would be used by multiple processes, we would have to map the entire virtual address range of every process to that NIC. Would that be a problem?
No, it's a virtual mapping. It's not really that big. I mean, when you say map represent the entire virtual address space, that's it. It's just address space. It doesn't mean that behind every possible range in addresses there is actual physical translation. Kind of rely on the Linux kernel. It tries to map a relatively consecutive regions. So it should be efficient.
Okay.
Okay. I believe this last presentation for today.
Artmey, are there more?
No, he mentioned this. Not much else. Last slide.
That's all.
Okay, thank you, Artemy, for staying late and again presenting.
Actually, maybe another note here. Can you please present the current status of enabling it by default?
Yes, currently we still do not enable it by default because we have a few issues with missing in driver to actually, but the goal, design goal is to once we have all fixed and we see that we don't degrade at least significantly in performance, we're going to enable it by default. Currently, it's disabled, still disabled. Should be enabled with argument.
And also the error handling. We currently don't support error handling with global VA, not fully at least. And there is a plan to introduce something like memory windows to UCT API to support it.
Yes.
Yes, UCX doesn't enable ODP by default if it's not coherent today, right?
So again, it's not exactly the same.
Right, right. But
ODP, like the way that you mean it, explicit ODP, will register a particular region.
Sure.
It does not have anything special, like it's just a flag. It's not exactly the same as that feature.
No, I agree with that, but my general question is, UCX doesn't enable implicit or explicit ODP by default for system memory in any case, right? It's
doesn't.
only recently that for coherent platforms that we added that, right?
Yes, currently ODP is enabled by default, explicit ODP on systems like Grasshopper.
Right. What about implicit? That's not enabled anywhere.
Implicit ODP is that feature of global VA that is
Right.
currently disabled because of the things that Artmey just mentioned.
Okay. And at some point when some of these issues are addressed.
Yeah, probably the plan is for 119 release.
Any more discussion, guys?
I guess I had a question on like what are the general critical path overheads now that if we move to implicit ODP and then page lock 2, then would it mean that in the critical path you pretty much experience no registration overheads? Is that the case?
There would be the memory lock overhead, and
Right.
there would be the fetch overhead.
Would the memory lock overhead not be one time because you pin pages and you leave it pinned?
Just like today with registration, it's,
Right,
it's
right.
also one time.
Right. So in the critical path it shouldn't show up. Like
It should not show up as today. It also should not show up today.
right. Okay. And this is what we see with explicit ODP as well. Because even though we don't pin those pages, in practice, when we test with any performance benchmarking, we see that latency is up to par with what you would see even if you register without ODP.
Part of that is because we use with ODP, both explicit and implicit. The actual function of the registration cache is to cache what we already prefetched. And it's like a best effort practice. The first time we use a buffer, we prefetch it. Hopefully it would remain in memory and not get swapped out. So to increase the chance that when we use it, there will not be much more page faults, which actually works well for benchmarks.
Okay, actually, I missed that point. So what is the default prefetch policy?
To prefetch on first use.
And so on coherent platforms, if we
Also
prefetch, then it would bring it to wherever the pages currently reside?
yes. Prefetch means that if the memory exists from an operating system perspective, then the NIC would also create the appropriate mappings.
Prefetch is a different term, right? Prefetch is like get the translation.
Prefetch means that NIC would prefetch the translation of existing pages that fall within the lines that we prefetch.
Okay, it's not actually the case that it would migrate pages. It's only
No, because it doesn't even know where to migrate.
Okay,
There's no like specific direction.
okay, good to know.